Hi everybody, welcome back to OPW University. My name is Dan Boyle. I'm the Senior Sales and Technical Support person over here at OPW. And today we're going to be talking about a question that's really come up a lot more in the last few years after the EPA changed their regulation. And that is, the questions we get are, what do I need if I'm going to take apart my edge bucket? Or what is necessary, what steps do I take to take the primary out and replace it? Or I'm getting a leaky seal on my collar, how do I go in there and repair that? So we're going to answer all those questions today. We're actually standing right across the street from the OPW plant at Jimmy's. So today I'm standing here, I'm wearing my bright yellow high-vis shirt, got some safety glasses on, and once we get in here to working on the spill bucket, I'll go ahead and put on my protective gloves as well so that we keep our hands free of that petroleum product. Now whenever you go out and do this, you're going to want to make sure that you're following whatever your company safety guidelines are. Check with your safety coordinator, review your OSHA guidelines. Safety is first and foremost for us, so we want to make sure we get that part right before we head out to the job to get the work done. So the first thing we're going to do today is we're going to open the spill bucket and we're going to clean out any of the residual product from the last drop. Maybe some condensation has started to accumulate inside that bucket. We're going to go in there, we're going to clean everything out best we can, so as we start removing components, we don't have any liquids or any kind of various items that are going to find their way into that tank as we start to remove things. So we're going to clean everything out of the bucket. After that, we're going to start to disassemble the bucket. And so today we're working with the 1C3132P, which means that we have a plug in there. There is no drain that exists. So we're going to go in, we're going to remove the 3-bolt flange, which is going to take out your fill adapter, your nipple, and the 3-bolt flange from our bucket. That's going to allow us access to get in there to the overfill prevention valve. Our 71SO testable is in there, so we're also going to remove that. And then if you were to have a drain version, you're going to want to make sure that you remove the split ring from the top of the bucket so that you could also remove the drain assembly. That does go a bit down into the bucket, so you have to remove that before you start to spin. Since we're working with the censored version today, we're going to leave the plug right where it is. We're going to remove the white poly adapter, and then we're going to take that sensor wire and push it all the way down into the secondary so that everything can spin freely and we don't have any kind of friction or anything in the way there to get in the way of our process. So let's go ahead and clean it out, which I have already done, and we'll get in there and we'll get started on taking this bucket apart. All right, so first we're going to need to disassemble the inside of his bucket, and for us today that means we're going to remove this 3-bolt flange. Now it looks like Jimmy's got his overfill valve set up in the high position, so he's not utilizing the face seal adapter inside the double wall edge. Both of these are acceptable installations, and we're going to go ahead and remove the 3-bolt flange and the drop tube and nipple and fill adapter all at the same time. Now that we've removed our overfill valve, fill adapter, and 3-bolt flange, next we're going to remove the poly plug that lives over the top of our sensor wire. Now there's a number of ways to do this. I made this cheap little tool right here out of a piece of conduit. You could also use like a wide chisel. There's any number of ways to get these plugs out. This is just the way that I've found works best for me. So now that we've removed the plastic adapter, we can see our sensor and sensor cable down here. So we're just going to push that down through the hole so that there's nothing to get in our way as we remove the 8 bolts in the rim, and that's how we're going to spin that primary out. So we'll tuck that down way out of the way. Now I'll clean this rim off, get some of that dust and debris out of the way, and then we'll take our 8 bolts out. And that'll remove our snowplow ring, and that'll give us access to our primary and secondary containment. All right, and then once we get those bolts out of there, we'll be able to clean the rest of it out before we put any of our seals back in. So there'd be a number of reasons why we would never need to do this process. You know, with the EPA regulations, buckets are being tested a lot more frequently than they used to in the past. So, you know, places up north where there's ice accumulation, sometimes truck drivers will get a little aggressive with their screwdrivers trying to break out some of the ice that might be found in here in some of the winter months, and they could compromise the primary with that screwdriver. We've seen that happen in the past. Or you know, this is one of the most trafficked across and actively used pieces of the UST system. Drivers are going to get in here multiple times and make their drops. That's going to change the environment inside our bucket, and it's also going to see more vehicular traffic on most sites than any other piece of UST equipment aside from a cover. Luckily over here at Jimmy's, this cover doesn't see a whole lot of traffic because he's got it blocked off from the rest of his lot. But should you ever need to get in, you know, we just wanted, this is not a terribly in-depth process, so we just wanted to give you the best view possible so that you could do this in the future. Try and keep any of that sediment away from our bolt holes as best we can. Scoop that down into the bucket. We'll be able to clean that bucket out here in just a few minutes. So now that we've got all the other components out and the snow plow ring removed and we can see access to our primary and secondary, the next part of this is going to require the use of our 1-3100 tool. This is going to slide right over our 3-bolt flange so that we can begin spinning the primary off of the secondary containment. Now, the most important piece of this is whenever you start to spin is you want to be looking down through the riser or over here at our snowplow ring bolt holes, so that as we start to apply this pressure and turn this bucket, we can make sure that only the primary bucket is spinning. If the secondary begins to spin, that means that it was installed likely improperly, not to the proper torque spec on top of the riser, and it's not going to allow our primary to spin out freely. So you want to keep an eye down through the riser or down through the bolt holes to make sure that you're only turning the primary containment. Looks like ours is looking good here. I'm only seeing the primary start to spin. So we're going to spin this all the way out. And there we have removed our primary containment, giving us access down into the secondary. So anytime we're going to do work on any of these edge spill containers, anytime we take it apart, we always want to make sure that when we go back in, we have good fresh seals that are clean and undisturbed from previous installations. So we're going to be removing the seals that go in between the primary and the secondary. And there's another seal that sits right on top of the primary, and that usually gets stuck on top of the snowplow ring. So we're going to remove both of these. And then also from this step, we're going to need to replace the 201972. That's an O-ring that can be located down in the bottom. It's on the nipple for the secondary base, and that O-ring is the one that makes our seal in between the primary and secondary containment. So we're going to go ahead and remove that as well and replace it with a fresh O-ring. So there's the O-ring on the secondary nipple. Anytime we replace these O-rings, we want to make sure we get them nice and greased so that next time somebody needs to come behind us, whether that's going to be in 6 months or 3 years from now, we want to get a good amount of, I'm using black moly grease. That's the grease that we prefer the best. It's a really long lasting, very viscous grease. So we're going to slide this new O-ring back over the secondary. We've got that secondary base all cleaned out, free of any condensation or any liquid that might have accumulated over there in the last couple of years. We've got it all cleaned out. And it's very important before you go back to put the secondary in, that you lay the sensor wire away from the secondary containment nipple, because that's where our primary is going to go, and we don't want any of that wire to get caught in between the threads while we're twisting the new primary back in. So since Jimmy's got a really good bucket here and it's only been installed for a couple years, he didn't actually have any issues. We're just going to clean his bucket up for him, and we're going to go right back in with the same primary containment because it's in good working condition, and we'll verify that after the installation is complete with a vacuum test. So now that we've got our first seal reinstalled, our next step is that we're going to go back in with these 8 set screws. Now these come in the replacement kit. The part number on these is 203171, and we're going to put these with a 3/16 Allen key. We're just going to use these to help us maintain our alignment as we put our primary back in. So we're going to just thread these down into our bolt holes so that the set screws are just above the first seal, and that's going to hold it right there in place as we start to turn everything above it. Now that we've got our set screws in, we can go ahead and put the new primary back inside, and we're going to push down on that with a 1-3100- tool, and that's going to give us the ability to turn that primary back in over that secondary nipple. So it's important to remember when you're reinstalling a primary that this is not an MPT style thread. So it doesn't matter how hard you can get this thing to tighten down. What matters is that we get it to spin. It's usually somewhere around 5 to 7 spins, and that's gonna sink our primary down low enough that it's gonna fully engage that newly greased and replaced O-ring that we just installed on the secondary, and that's what's gonna make our seal in between the bases of the primary and the secondary. Give it another half a turn. So a good check on the primary is we want that primary to be installed between 40 and 100 foot-pounds. So one of the things the 3100 tool allows you to do is if you remove the post from the adapter that goes over our 3-bolt flange, and you remove the post, it shows you this nut up on top. And the reason we put that there is so that you can put a torque wrench right on top to ensure that you're within the range that OPW specifies, which we know will give this bucket a really good seal. So that bit on top will fit a 7/8 socket, and we're just going to put torque on there to make sure that we're within the range. That's right about 86 foot-pounds that it took me to get there, to get it right where we need it to be, which is square of the range between 40 and 100 foot-pounds. So now that we've got our primary in place, we're going to remove our set screws, and we're going to set our new gasket right up on top over the lip so that we can reinstall our snowplow ring. So now that we've got the primary back in, we just got to go on a little fishing expedition so that we can reach in there. I just grabbed some needle nose pliers to reach in there and grab our sensor wire. We got to make sure we stand that sensor back up so that it reads properly. And then we're going to start going back in, and we're going to remove one set screw at a time while we go back in with our new seal that goes over the top, our plow ring, and then we'll start putting those bolts back in. I just like to do a little bit of grease on each one of these bolts just to think about the next guy, whoever might come behind me. And we want to make sure that whenever we're going back in with these bolts that we're torquing them all back down to 25 foot-pounds. And now when we're removing these, we want to do it just like you're changing your car tire. We want to go on a star pattern so that we're getting equal compression all the way across the snowplow ring. So there's 25 on the first two. Now to save you all a little bit of piece of your life here, I'm going to go ahead and we're going to work some movie magic, but I'm going to move over to this bolt next, then to here, then to here, then to here, then to here, then to here. See you in a second. Now that we've got all of our snowplow ring bolts reinstalled, next we're going to go back in and resituate our sensor and put our sensor adapter back in. Now, same with any other seal, since we pulled this out and we've made replacements, we're going to go ahead and remove the seal that was on the adapter. And the O-ring, the part number for this O-ring is 201972. So I've already gone through and I've scrubbed this adapter, these adapter threads with a wire brush, and I'm going to do the same with where it's going to be seated. And I'm going to lubricate this O-ring with the same black moly grease that we did the secondary containment O-ring, so that we get a good clean seal and there's no dirt or debris in the way. So we got a well lubricated sensor adapter plug. We're going to make sure that we stand our sensor wire right back up through the little sliced V there, so we can get it to stand still. Now that it's upright. And then when we go back in with our sensor adapter, again, these are straight threads, so it's not going to do you any good to get this as tight as possible. That O-ring that we've greased and cleaned out its seating area is going to be what makes our seal on the primary. So now that we're nearly all the way back assembled, we still need to put in our overfill valve, 3-bolt flange, and fill adapter. Since we've got this all taken apart, we want to make sure again that we want to take care of the guy behind us. So I've already gone in here with a wire brush and I scrubbed off all around the sealing surface where the 3-bolt flange is going to sit, and then going back in with just a little bit of cleaner on a rag, and we would just want to make sure that we get all that dust off so we have a good clean seal. Now I'm going to go put some black moly coat on the O-ring that exists on the 3-bolt flange, and we'll reinstall our overfill valve and 3-bolt flange in just a second. Be sure when you're reinstalling your overfill valve that you close that flapper so it can easily slide inside the riser. And the area which we want to grease for the 3-bolt flange is going to be right underneath the 3-bolt flange itself, all the way around that O-ring. So now we're going to keep putting this thing back together here. We're going to take our 3 bolts for our 3-bolt flange, put a little grease on them, get them started, and we're going to tighten each one of these down to between 20 and 25 foot-pounds of torque. So now that we've got the entire bucket put back together, cleaned out, re-greased, freshly lubricated and reinstalled, the last thing we need to do is to make sure that now that we've got our bucket put back together, that it is testing tight, it's holding vacuum, and that we're keeping our UST system as tight as it was before we took it apart. So the DW-VAC-test is a vacuum tester that we sell. It comes with this little adapter that's going to go right on the test port on the inside the primary of our double wall edge, and then we're going to air this up to minus 15 inches on the water column. All right, so we actually let this sit a little bit longer than intended while we were chatting, so we were about 6-7 minutes here. Looks like we fell down just about 1 inch on the water column, which is most likely coming from that air settling on the vacuum from where we got it. It just needs to stay above minus 12 inches of water column for that to be a good pass. We do allow a little bit of variability for reasons just like we had here. So we know that this bucket has been taken apart, reinstalled, and it is now tested that it is tight and in good working condition. Well, I hope this has been helpful. Again, the number of reasons that you might see this is because of the more increased aggressive testing for every 3 years as a requirement by the EPA, and it might even be more in your state. Or it could be that a driver came in and said they accidentally got into it. There's a number of reasons why this could occur, but one of the major benefits of the reason that I like the Edge bucket so much is because there's not a single piece of that bucket that you can't take apart and replace without breaking concrete. So it really drives home the idea that investment over the next 5, 10, 15 years or what have you, that you're going to only have to buy that one bucket once and you're only going to have to install it once. The rest of the maintenance and replacement can always be done above grade. Just a couple of the key points that I just want to reiterate one more time is that whenever you're doing this, after you're taking all the things out, you want to make sure that you're hitting them with a wire brush, making sure that you have clean equipment to go back in. Another thing is you want to make sure that you are always replacing the gaskets and O-rings. These are what keeps our bucket tight for the longevity of the product. So when we go back in, we put those fresh ones, we want to make sure that they're well greased and they're going to last for a long time. And it's going to be easy to take apart and put back together next time you do this. Typically an installation like this takes somewhere around 60 to 90 minutes. That could take longer if the bucket is 10 years old and hasn't been well taken care of, or somebody could have worked on it 6 months ago and everything comes out quickly and you can be done in half an hour. And the last matter of importance is that whenever you're taking these apart, putting them back together, or installing it for the first time, the use of a torque wrench is absolutely imperative. So thanks again for tuning into OPW University to learn more about the double wall Edge spill bucket. If you have any additional questions, please go to opwglobal.com or reach out to the district manager in your area. Thanks again.